Russian administration allegedly revealed a design of the weapon indicating that it will carry a 55 megaton nuclear warhead similar to Tsar Bomba, the world's heaviest nuclear weapon. Tsar Bomba was the world's most powerful bomb. It was a thermonuclear weapon developed by Soviet Union scientists. Tsar Bomba had a yield of 50,000 kilotons of TNT. On the other hand, the Hiroshima bomb had a yield of around 16 kilotons, one of the biggest nuclear weapons detonated on the Earth. The effects of this blast was drastically huge. In late 1961, Tsar Bomba was dropped from a Tu-95 bomber aircraft at the north of the Arctic Circle. The explosion unleashed about a 45-mile high and 60-mile wide plume of smoke and damaged homes as far as 35 miles from the bombing site. It was so severe that the shockwave traveled thrice around the world. Tsar Bomba was the only biggest nuclear weapon ever tested. Moreover, nothing such was made after that. On the contrary, nuclear scientists believe that this biggest nuclear bomb underwater will trigger a massive tsunami only in local and nearby coastal areas. However, it won't affect the whole world. An undersea nuclear explosion leaves no trace at the surface other than hot, radioactive water rising from below until it breaks the water surface while still a hot gas bubble. As water is not easily compressible, moving out of the way requires a tremendous amount of energy. This comes from the growing bubble's pressure due to the nuclear explosion. Outside water pressure forces the bubble to collapse back into a little sphere and rebound, which is repeated several times in just a few seconds. But each rebound carries only 40% of the preceding cycle's energy. This simply means that every rebound decreases 60% of its energy. Effects of underwater explosions are far different from in-air or land explosions because of the properties of water. The density of water is much higher than that of air, thus making it harder to move. In physics, it is called inertia. Inertia is a property of matter which means the matter continues to exist in the same form or has a uniform motion unless an external force is applied. Moreover, water under pressure in a low range is hard to compress, which increases the density. Thus, these two properties of water make it a great conductor of shock waves by an underwater explosion. The majority of underwater explosions occur in salt water rather than fresh or clean water. Seawater consists of salt, chemically known as sodium chloride. Sodium and chlorine atoms present in salt water rapidly absorb neutrons, resulting in radioactive isotopes. The time required for half of the sodium atoms to decay is around 15 hours, whereas the same for chlorine is 300,000 years. In nuclear science, it is referred to as half-life. The half-life of a radionuclide is the time it takes for half of its radioactive atoms to decay. Such a radioactive reaction leaves back sodium, the most harmful pollutant left over following the explosion. Radiation contamination is removed by simply distilling or evaporating water as a result of the heat produced and leaving the radioactive salt behind. The distance from the explosion, the force of the explosion, the depth of the explosion, and the depth of the water all influence the effects of the underwater explosion. Underwater explosions that are shallow leave a big crater on the water's surface, whereas deep explosions have a small crater, or sometimes none depending on the depth of the explosion. A nuclear bomb detonated under the ocean's surface has the potential to cause chaos. The underwater nuclear weapons tests conducted by the United States in the 1940s and 1950s, such as Crossroads Baker and Hardtack Iwahu, revealed the reason. The bombs detonated on Hiroshima and Nagasaki in 1945 were about as powerful as these underwater fireballs. These explosions shattered the surface in the experiments, ejecting pillars of salt water more than a mile high and causing massive shock waves. Due to this, some vessels were annihilated, others sunk after being thrashed around like toys, disabled engines, and other similar damage. The force of explosions increased the height of waves that hit surrounding islands and flooded inland towns. According to nuclear scientist Greg Spriggs, A 50 megaton weapon might theoretically create a tsunami and impact a coastline with the energy around 650 kiloton bomb. Even the most powerful nuclear weapons are unlikely to cause a powerful tsunami if detonated underwater. Any wave triggered by a nuclear explosion would be small. The tsunami that hit Japan in 2011 discharged about 9.3 million megatons of TNT energy. That's far more powerful than the Hiroshima bomb, and 150,000 times more powerful than the Tsar Bomba. All the energy of such deep underwater nuclear explosions near the coastal area will not be directed towards shore. It will spread in all directions, wasting the majority of it into the sea. An explosion many miles from the coast would only deposit about 1% of its energy, as waves will hit on the beach. Moreover, if this nuclear bomb is dropped in the deepest part of the ocean, the Mariana Trench, then there are chances that nothing could be felt above. The Mariana Trench is said to be the deepest point in the ocean. This crescent-shaped trench is in the western Pacific Ocean, 125 miles east of the Mariana Islands. The length of this trench is about 2,600 kilometers, and the width is 70 kilometers. Did you know? The Mariana Trench covers an area 5 times bigger than the Grand Canyon and is 8,000 feet deeper than Mount Everest, the world's highest peak. The temperature is exceedingly cold here, and the pressure is 1,000 times higher than that above the sea level. The explosion at the Mariana Trench's bottom will produce a rapidly growing spherical chamber of hot steam. In a matter of seconds, the bubble expands to nearly 1 kilometer in diameter. Over a vast region, the water then bulges up, but only slightly. Then it collapses due to the pressure of the 6 miles of water above it. The bubble decreases to minimal size in a dozen or so seconds, then will bounce back, spreading outward again. No wave of any significance will be formed as a result of such a deep water, closed bubble production. According to the calculations made by scientists, this nuclear explosion in Mariana Trench would spread up to 600 meters only in radius. This will hardly reach the surface of the Earth from the 36,000-foot deep Mariana Trench. The swirling warm water generated due to the explosion is fairly large. The rising heat column generates a hot patch in the ocean, which is many degrees warmer than the surrounding water, lasts for a long time, and then condenses. Before 1963, many such tests of nuclear weapons had taken place in the ocean to see the after effects of nuclear explosions. In 1946, the first underwater nuclear explosion took place at Bikini Atoll off the coast of the Marshall Islands. It was named Baker, and the nuclear capacity was equivalent to 23 kilotons of TNT. It was one of 2 nuclear tests of Operation Crossroads to see how nuclear bombs impacted Navy vessels. Baker was hung 90 feet underwater and detonated in the center of a fleet of targeted ships. The explosion underwater obscured a blinding glare. Photographers were set 2 miles on an island to capture the event. Another such test, named Wahoo, was done in 1958. Wahoo generated a spray dome that rose 280 meters above the ocean's surface, followed by a hot gas and steam bubble that broke through. It sprayed water in all directions, up to 580 meters in height. When the cloud collapsed, the base rushed forth for 2 miles downwind, reaching a height of 300 meters and moving at 80 miles per hour for the first few seconds, and then dropping to 25 miles per hour. Well, nothing much to worry about, as these blasts are less effective offshore, even though they are as big as Tsar Bomba. Moreover, as these tests were polluting the ocean, and such nuclear explosions were against environmental conservation, in 1963, the Partial Test Ban Treaty prohibited atmospheric testing due to worries about radioactive fallout from such tests. The US, Russia, and the UK were the initial members of this treaty. Later, France joined them in 1975 and China in 1981. This treaty permits nuclear testing within a member state's boundaries, but not if radioactive material travels outside those limits. This effectively rules out air, space, and underwater testing while allowing underground testing. We hope you enjoyed the video. And don't forget to share it with your friends who would love to know more about such topics. Subscribe to the channels and click the bell icon to stay updated on upcoming new topics.